Okay, cool. Hi, everyone. I'm Geoff McDonald. Today I'm going to be talking to you about large generative language machine learning models and their upcoming impact on cybersecurity. I'm Jeff. I manage a team of data scientist teams who work on Microsoft Defender for Endpoint. We work on both the antivirus product as well as the EDR product and network protection product. I'm personally based in Vancouver, Canada. A lot of our data science teams are based in Redmond and across the U.S. Although we do have some data scientists, research teams here in Vancouver as well, and we do have a lot of security and reverse engineering teams actually based here in Vancouver as well. Cool. Yeah. So I guess about me personally, I have a background in cybersecurity. I've done like reverse engineering, particularly on the antivirus product, and I've done a bunch of deep security research for probably about maybe 5 years before transitioning into data science, which I've been working at for approximately the past about 5 or 6 years now. Cool. So my talk today is going to be introducing you to some of the the large generative language models. So I'm specifically going to be talking about the generation task large language models today. So I'm just going to enable my laser pointer here. So generally these are I'm talking about the generative language models, which generally read text from left to right. So like the malicious document is, and then they sort of predict the next token that follows. A token is sort of like a word. However, less common words will be broken up into multiple tokens. So a token can represent a whole word, it can represent a set of characters, or like a single character even as well. So for example, it might predict the next token in this is any one of the following words, and then it's going to randomly sample one of those words. In this case, it's going to say that the next word is bread. So this can be repeated. This can be repeated multiple times to autocomplete whole sentences or whole paragraphs, or you can get it to generate whole stories all by itself, for example. So if we were to predict the full sentence here, we can say this document is read via fish, phishing emails, period. So you can see, for example, phishing was not as popular of a word in the vocabulary that the model is trained on, so it actually split it into two words, for example. So these large generative task language models are trained to predict the next token from a very large collection of text. And then they read the text from left to right, and then they predict the next token that follows. And they can be used for many different sort of tasks that we're going to see here today. So these models are generally trained, these large language models are trained from very large corpuses of text data. One of the most common training sets is called the pile, which is almost a terabyte of text data. The training data comes from many different sources. Like the largest one is Common Crawl, which is like for crawling of websites, but it trains on the contents of books, GitHub, research papers. You'll see like Wikipedia is included here. So it actually trains on a mix of both text as well as code content. And it actually, through this training process, gets a good amount of understanding about a broad variety of fields, including cybersecurity. So this can be used in, like, you can do question answering on cybersecurity documents, like what is a supply chain attack? And it will autocomplete a paragraph describing what a supply chain attack is, for example. Cool. Now I'm going to quickly cover what zero shot, one shot, and few shot learning is. Um, so with these large generative models, you don't actually need to train the model to your task. You can actually just use these really large generative models to apply to your task without any training, without any label data or anything. So the first example is like, imagine you want to translate English to French. So you might use a template where the text is English colon, and then you'll write in text the English sentence that you want to translate, and then you type French colon, and then get it to predict the next characters of the output, the next tokens that are output, and you hope that it understands that you're trying to translate that the French colon is sort of going to be the French translation of the same sentence. So using this, you might say English, our cloud service will host 10 nodes, French colon, and you predict the next characters, which is the output, and you hope that this is the proper French translation. So you actually didn't train the model to do English to French translation. You're just using the next token prediction in order to get it to do the translation task, so more like generalized intelligence. So few-shot learning is where you give it a couple examples of the task that you're performing. So in this case, you give it a couple, you let it read a couple translations first. So English, French, English, French, English, French, and now you apply your translation task. So here it has a bit of an understanding of the format of the output that you're expecting, and you'll get a much better result usually. So now you apply the translation task with what you actually want to translate. So again, you haven't trained the model, you haven't provided really any label data, you've just sort of provided a template with a few shot examples. So here's a quick plot of like, how much that impacts the quality of the models. If you do zero shot, you can see the quality of the models perform not very good according to the accuracy in some of the tasks. However, even if you give a single example of the format you expect, it gets way better results, and it gets quite a bit of results up to 10 shot examples, and beyond that, it gets even more improvements. So again, you're not training the model, you're just providing a template with a few shot examples. Now you can actually train the model to fine tune the models as well to your task, to your task as well. So imagine you might have maybe 100 English to French translations already that maybe even used a few shot or zero shot learning to help you create because maybe you don't know French at all. But once you get like a few hundred examples, you can maybe do a few training epochs of these large model on the data. So you're just slightly adjusting the really large model to learn from your specific task. And then you might use it in zero-shot learning, which makes it a bit cheaper to inference the model. Okay, now I'm going to give a couple examples of what these types of machine learning models are used for. Uh, one that you probably see the most is probably autocomplete. So for example, if you're autocompleting emails, maybe automatic suggestion for what you should reply in a text message, a lot of these would be using these type of really large machine learning models. And here's an example of some security problem on them. If you're training obviously with customer data, it could reveal some information. If you've seen this XKCD comment, it's pretty good. It's also used a lot it's also starting to be used in code writing. So I highly recommend checking out GitHub Copilot. This is more in code generation, and I've given it a try. I've used it in some of my personal hobby coding, and it's been amazing. It's been blowing my mind with the proposed solutions that it proposes, and it's an extremely useful asset already in coding. So basically, you can write the definition of the function, maybe a comment of what it does, then it's going to write the whole function for you, or it's going to propose many different solutions to the same function for you. You can also use it to. I often would use it more to write code filling just part of the routine. Like you might write a comment, this part I'm going to take the data frame and I don't know, featureize it in a certain way, then it will suggest the code to autocomplete that for you. And it's been kind of a really amazing experience. I highly recommend signing up for the beta and trying it out with VS Code. It's also used, for example, in games, starting to be used in more games. There are some text writing games where you can basically interact with a more like a choose your own adventure game where you can write whatever you do in the world and then it will generate what happens in the world in response to what you said. So it's a completely open-ended choose your own adventure text generation games, and I highly recommend trying them out. It's quite entertaining. So in terms of these models that do the generation task of the large language models are extremely big. Most of these models can't be run on your local device, even like with a really large GPU. They generally have to be. They can't load the whole models onto a single GPU. You have to run multiple GPUs in order to even inference them. Um, One thing to note here is probably most of the largest models are closed source. They're not open source. The largest open source one that I'm aware of was released a couple months ago. The GPT Neo X 20 billion is the largest open source model. Now, pretty much anything 12 billion and above is applicable for most of the cybersecurity attacks that I'm about to demonstrate, especially when fine-tuned to the application. Now, what I'm going to be demoing today is the OpenAI GPT-3 Da Vinci, which I'm going to be demoing for all the attacks here today. Cool. So now I'm going to start with all the fun stuff. I'm going to show about how all the cybersecurity risks these text generation models have, at least some of the ideas from my own experimentations that I see as the risk to cybersecurity. And I'm going to demo each of these attacks as well. So the first one is, I can't move my mouse anymore. Okay, cool. I think I froze. I hope everyone can still see me. Perfect, good. Okay, so So the first one I'm going to demonstrate is phishing, targeted phishing emails at scale. So this is the OpenAI playground that I'm going to demo with here. Perfect. So what this is we're doing a few shot learning. So I give a couple examples of targeted phishing emails. You specify the target, like the company of the target for the target phishing email attack. You target the person who you're targeting within the company. You talk about the role within the company, and then you provide the payload URL that you want them to click on, for example. So in this case, I give a total of 1, 2, 3. I give 3 examples, and then I carry out a generation task where my target is going to be from Walmart. I'm going to be targeting James Scott, who works in public relations, and this is the link I would like to use. And now you can sort of generate. You can generate these phishing emails, and each time you generate it, it will generate a different phishing email. I'm just going to let it finish here. I think it's still generating. Perfect. There we go. So now here's an example of a targeted phishing email. I'm going to try regenerating a few times to see if I can get a more PR focused one. Often we'll get some better examples here. Perfect. So here's another target phishing email. I'm going to cross my fingers. I want to get a good one targeting PR. Perfect. Okay, yeah, no, this looks like a pretty good one. Okay, so it says I'm going to wait for this to finish generating. Perfect. So I hope this email finds you well. I'm a journalist with the Wall Street Journal, and I'm writing an article about Walmart's public relations strategy. I would love to speak to you about this topic and your insights. You can find more information about my article at my website here. I look forward to hearing from you. And you can really write whatever name you want, and it's gonna generate a target email to the specific target. Okay, cool. Yes, back to presentation. I'm sorry, it looks like my PowerPoint actually crashed. So just give me a minute. Okay, cool. So I'd say like the targeted phishing emails at scale, I think it's an immediate high risk problem. If you combine it with for example, scraping of LinkedIn profiles, or for example, business listings, you can create targeted emails at scale specific to the person's role, specific to the person and the company. And I think it's going to be starting to change some of the phishing techniques that we see. The defensive technologies that rely on the same large natural language models, I don't think get as good of a benefit as for the attackers, unfortunately, in this case, because the emails that are generated with this are generated to more closely look like a real human that's writing the content. I think a lot of the defenses in this case are going to continue to be based on like sender and URL reputation in order to detect and protect against these attacks. Cool. So now I'm going to apply it to the next task. I'm going to be talking about how it can obfuscate PowerShell script. Perfect. Perfect. So again, we apply like a few shot learning template here. We give it 2 examples of PowerShell script unobfuscated, and then we provide an example of it obfuscated. So in this case, we've added a whole bunch of very basic string obfuscation in order to try to avoid AV detections or EDR detections. And then another example of using invoke obfuscation. Here's an example. And then you can then here's an attempt of trying to use it to obfuscate this input PowerShell command. And in this case, we give it a hint to use super advanced obfuscation in this case. So now I'm going to generate a few examples using this. Sometimes you'll get like almost no obfuscation. Sometimes you'll get some sort of basic obfuscation. And sometimes we get completely wrong solutions. Like in this case, that was not a good real answer. There's, again, no obfuscation at all in that case. Now, I think we're starting to get a basic obfuscation example once it finishes. Perfect. Cool. So now here is sort of a sort of more simple obfuscation where they've sort of hidden the characters involved with it. So sort of my assessment of whether that would be sort of the use case to create obfuscated PowerShell script. I don't think it's a very effective method. I don't think it's an improvement on the existing attacker techniques in the way that they obfuscate scripts. I think it doesn't model the way that the attackers generate their obfuscated scripts either, because I think they're writing coding routines like you can imagine like a Python function, which will do the obfuscation of the PowerShell script. So it doesn't really closely match the techniques, and it can't match the same complexity that would be involved either. So I think instead of using it to directly obfuscate the PowerShell script, I think what it's going to be used to do is to author code which obfuscates PowerShell, and I'm going to give a demo of that now. Perfect. So in this case, we're starting to define a Python function, build malware loader, and then you specify the URL that you want it to download the payload from. You give it a short comment as what you want the function to do. So in this case, we're going to build an obfuscated PowerShell command to download and execute an executable from the specified URL. So then you get it to author PowerShell script here, which sometimes will have a decent output. I'm just going to let it finish generating this function. Perfect. I'm going to go ahead and generate another one as an example. And I'm going to try generating one last one after this one finishes. Perfect. Yes, so sometimes it doesn't do a very good job. Here's one of the best examples I got for code generation. This one was from GitHub Copilot, actually. So it's the exact same function. And it actually was able to output a solution which XORs each of the bytes with 9. For example, he's XOR encoding. And then it actually authored a PowerShell script, for example, here, which would go through and XOR each byte by 9 to reverse it, and then execute the PowerShell command, which would then download the file and start the process, for example, which is a pretty good example. But you do get a lot of cases where it creates failure cases where it won't generate successful script content. So, but I think you can combine it with unit tests where you can generate, 100,000 or tens of thousands of these routines and put them to unit tests into scripts functions that actually generate PowerShell code that successfully executes that URL would be the test. And then you can basically get it to author many different Python functions, which will generate Python or PowerShell loaders for you with many different obfuscation techniques. So that makes it harder for the defenders in order to detect the attacks because of the wide variety of techniques that they'll be using to obfuscate their attacks. One thing to note is it does understand, like, it can begin to understand more complicated asks as well. Like you can say, build an obfuscated PowerShell command to enable RDP and send credentials to a specified URL. Now, this is too advanced for where the models can be right now. But for example, the models do recognize how to enable RDP on the device, for example. So it starts to get some of the more complex parts already. You can also get it to generate like other coding languages. It doesn't have to be PowerShell. You can get it to generate Office macros, VB script, or JavaScript loaders as well. So I'd say like it is an immediate risk, but I think it's not a great improvement on the techniques that the attackers are currently using. It might increase the diversity of the script attacks that we see, but I think it's not like a great improvement, not like a humongous improvement upon the existing attacking techniques here. This technology can be used defensively in this case as well, and I'd actually argue that it maybe benefits the defenders more in this case because you can either generate a large number of diverse attacks using this approach as the defender, then you train a model to classify all these attacks, even if though they haven't been observed yet. Or you can train like a large NLP model using similar transformer models to do in binary classification tasks, because these PowerShell scripts and macro content really isn't trying to look clean, so it makes it fairly easy to identify as malicious by these large language models. Okay, cool. Now I'm going to go into more of a futuristic one, which is automating a human-operated ransomware attacks on an enterprise. I'm going to go ahead and demo this example. Perfect. So for example, you can give the model a little bit of context of what the objective of the attack is. You can say, here we are carrying out an attack using Metasploit on an enterprise. The attacker goal is to infect a machine, elevate privileges, and move laterally to the domain controller. Afterwards, we'll push out a policy to encrypt all devices on the network. And the attacker could even specify the exact URL to download the payload to do the actual ransomware encryption, so that they'd actually encrypt it with the right key and everything. So you could add that, the attacker can add that to the description. So then you can get it to output like the first commands that it would do to create the phishing kit. I'm going to go ahead and retry this a couple times. Perfect. So this obviously didn't generate the right code. It's trying to exploit the internal blue vulnerability, but I'm going to go ahead and assume that was sort of right. And then I'm going to assume that you have like a reverse shell. Then you ask what your next step is going to be, and then it's going to generate the next steps once you have a reverse shell on the device. So it says it's going to execute a privilege of escalation. And then often it'll do like a credential access. Yes, then it does. Maybe I'm actually not a super expert at Metasploit, but I imagine some of this will be somewhat right, but I imagine it won't be actually technically correct. So then, for example, it'll run the credentials, your credential manager. Let's assume that this would then give us the credentials. I'm going to go ahead and go to the last stage of the attack. I think it gets really interesting. Perfect. So let's say now for the last stage of the attack, I think you can basically effectively loop giving the output of the command that they give. You successfully got the credentials, and then next I'll do the following. So basically you do the next action of the steps, then you give the output back to the model so it understands the output of the tool that it runs, and then you repeat the step indefinitely in order to let the AI start to learn about the environment that it's attacking, as well as respond to the output of the tools in more like a human-like way. So perfect. And I guess attempt to do escalate privilege again here. Perfect. So basically, once you basically repeat this loop of you see the output from the tool, and then you ask it what the next commands that should be ran. So if you repeat this process repeatedly, you can get it to respond reactively towards what it's seeing in your environment and the output of the tools that it's running, and then it can eventually, once these natural language models get good enough, it is going to be a risk to be able to automate a human-operated ransomware attack, where you could be automating Metasploit or Cobalt Strike on a network, and you just give it in general terms, like general written English, what the goal of the attack on the enterprise is, which is to download human-operated ransomware encryption from a specified URL on all devices and execute it, for example. I would say that this is a distant high risk to cybersecurity. Probably in the next decade, we might be able to see there might unfortunately be large enough advances in NLP that could make this a real risk, and that's going to completely change the cybersecurity game because now they don't need human experts to carry out the attacks. Defensive technologies benefit from these same advances. However, it's more costly for defenders due to the scale of this log of the security logs, and these large NLP models are really expensive to run over a large amount of data. These can also be used for propaganda, fake news, and social media attacks. I'm going to go ahead and show you some examples of those. So in this case, you can define, say, your platform. I say I'm running for the Prime Minister of Canada, for example, and maybe this is the platform, my election platform. And then I describe that my tweets are going to be aggressive and attacking and discrediting the person that tweets. And then I give it a couple examples where a person tweeted something, and then I give a reply to it. So this is, again, two-shot learning. And now, in this case, someone's tweeted this: Geoff's plan is crazy. We can't just steal crypto. We need a real jobs plan. And then it'll generate tweet replies to it. So basically, you can automatically create fairly intelligent social media interactions, um, social media social media interactions which promote specific agendas, or it could be against specific people, or it could be promoting like your political candidate or attacking opposing political candidates. Um, so this is obviously, I think this is a current problem. This isn't probably anything new that you probably haven't heard of before. Um, but I think, like, in terms of like propaganda, fake news, social media attacks, I think a lot of what's being done currently is like human generate content. But I think, imagine some of it already is these large generative language models creating content towards their specific platforms as well. So I don't know what the solution should exactly be here. I think like Elon Musk is saying, hey, they're going to add identity verification to all users of Twitter. Like, we can have strict identity validation in order to help solve this problem. However, obviously that comes at its own privacy cost as well. This can also be used to fully automate, starting to be possible to fully automate scam attacks. I'm going to give a quick demo of what that looks like in an automated scam attack. So um, so for example, one of the Facebook scams, and this is one that I've seen myself as well, is that the attackers will compromise a Facebook account, uh, usually using a weak password of some inactive user. Then they'll go join some Facebook groups, like parenting groups, for example, and then they post like a sob story there. They'll post a sob story, and then how the scam works um, is that they hope that people initiate conversations with them to help cover whatever scenario they're in. So then they start a chat with the person and they ask them to basically send them money, is how the scam works. So you can get it to create targeted scam emails, which then could be posted to the Facebook groups, and then even the chat conversations within, like, Facebook, for example, could be fully automated, where the AI is reading the chat in response to the story and come up with sensible replies to even fully automate the human interaction, the human conversation part of the attack. So basically, I think the whole scam campaign could be automated already with the current technology. It might not be as effective as a person operating it, but I think it would have a good amount of success that it is starting to become a risk. Okay, so I guess in conclusion, targeted phishing emails at scale is an immediate risk, and it does not equally benefit the defenders. Automated malware loading and authoring is on the verge of being effective, uh, and I'd say luckily, it benefits defenders more than attackers, I think, in this scenario. Automated human-operated ransomware attacks, I think, are on the horizon, but this is more on the, like, within the next decade type horizon, which is going to be which would be like a really big game changer for the cybersecurity field. Disinformation is already a problem, and scams of the future, I think, are going to start to leverage these models as well. And I highly recommend playing with these models yourself. You can try out the OpenAI API. You can sign up for it. You can sign up for the beta for GitHub Copilot for the code generation interactions. Goose AI is a lower cost implementation, of the open source large text generation models, which you can try out. And I highly recommend trying out the games that work with this technology as well. Yeah, thank you, everyone.